Alright, finally, the final algebra part of Module 7 is kind of the culmination of everything, solving exponential and logarithmic equations. I have given you 3 exponential equations, 21, 22, and 23, and then 3 logarithmic equations, 24 through 26. I will do 21 and 24, an example from both, and then you're expected to do 22, 23, and 25, 26. Now, if it is an exponential form, as 21 through 23 are, again, the first reason I know that is that there's powers. Alright? I'm actually going to do 22 because it's a little bit more involved. Why is my writer thing not working? Oh my. What did I do? Hold all the thoughts. Hold them all together here. I don't understand what it's doing. I want to write with my reading pen. I'll do 22, you do 21 and 23. For 22, I know that it's exponential, for one, because there isn't a log written, and there's powers that exist. In this case, 36 is being raised to the 2x plus 1. It's important to keep in mind that 216 is also being raised to a power. I know it to be 1 because it's not listed. For solving equations that are in exponential form, I have to identify the bases. You still have to do that for logarithmic, but it's important for exponential. The base of 36 and the base of 216. And again, if you remember, you should by now, we practice this a lot. In order to solve these types of equations, you have to get the bases to be in common. This is where you would refer to your power sheet. I don't have that on this form, but if you have a question on it in class, you can ask me. But you'll look at your power sheet and you'll try to find a column that has the same base that is raised to a specific number that will give me 36 and will give me 216. In this case, if you looked at the column of the sixes, base 6, 6 to the square, or 6 squared, 6 to the 2, I'm sorry. So I'll side note that. 6 squared equals 36, and then 6 to the third, is it? 6 to the third equals 216. In the column of sixes, you should see then that I find a 36, I find a 216. They can be written, 36 can be rewritten as this, 6 squared. 216 can be rewritten as 6 to the third. That's what I'm going to do. Instead of 36, I will rewrite 6 squared. Instead of 216, I will rewrite 6 to the third. Now, another piece of information that is very important. The 36 and 6 squared is the same thing, just written in a different way. The 36 originally had this power already there. So since I'll go to blue. This power and the power of 2 need to interact with each other. They're being multiplied with each other. If that situation ever exists, you have to multiply the power that already exists with the new power you just made. So it's going to be 2 times 2x plus 1. And now, this equation is happy because the bases are the same. I'm going to go ahead and do this math. Again, that since 2x plus 1 existed in the powers, I need to multiply them together. I will go ahead and do this math as I drop them down. Since the bases are happy, remember that's the whole point of doing this. You can just work with the powers now to solve for x. But I'm going to do this math, 2 times 2x and 2 times 1 to bring it down here. 2 times 2x is 4x. 2 times 1 is 2, so 4x plus 2 equals 3. And again, the bases, I'm not interacting with the bases anymore because their powers are the same. Now again, that step to get to right here, to turn into a linear equation, this math will look different for the rest of these problems. Just depends on what you end up with your powers. But in order to solve for x, my variable, I need to subtract 2 from both sides. So I get 4x equals 1. And then I have to, in this case, 4 and x are being multiplied, so divide by 4, x equals 1/4. And I'm done. Try 21 and 23. Now, in this same video, I'm going to talk through I guess I'll make it a new video.
Do.